Once again, welcome to the channel of TKG physics classes. So students, we already completed 2 lectures related to your third chapter, that is current electricity. Now this is a lecture number 3 of current electricity, and in this lecture we will discuss, that is in this lecture our key point, this one. First we will discuss Ohm's law. All of you know about this formula, Ohm's law. Then we will discuss resistance, the basic of resistance. We find out the units, dimension. Then we find out the factors affecting the resistance. That means resistance depends upon in which factor, etc. Then we will find out the resistivity. Then we will solve vector form of Ohm's law. And finally, we will solve some numericals related to this formula, R is equal to rho L by A. So before starting this class, just recall the previous class, because this is the best way out for connecting all of you with this class. So in previous class we derived drift velocity, then we find out the relation between drift velocity and current, we find out the relation between drift velocity and current density. Okay, so just begin the class. First of all we have to know about Ohm's law. All of you know about Ohm's law. In your class 10 there is a current electricity chapter. So what is Ohm's law? If we consider a conductor and this conductor is connected with a battery of potential V between 2 points, this one potential V between 2 points, then according to Ohm's law, German scientist Siemens Ohms in 1828 discovers this relation experimentally, and the relation is the potential difference between 2 points in a electric circuit in a conductor is directly proportional to current flowing through this conductor. Condition applied when temperature and other physical quantity remains constant. Okay, this is the important part. When temperature and other physical quantity changes, this Ohm's law is not valid. And the Ohm's law statement is the current flowing through a conductor is directly proportional to the potential difference between 2 points of that conductor. So we can say if a current is flowing I and the potential difference is V, so according to Ohm's law, we can write V is directly proportional to I. So we can say V is equal to R into I. What is R? Here R is the proportionality constant, and this proportionality constant is known as resistance. So write it down first. So here R is equal to V by I. This is the formula, and this is the form of mathematical form of Ohm's law, and this is the formula for resistance. Now here this value, this constant part, according to equation you can say this is directly proportional to V, this is inversely proportional to I, but no, this R, this constant is a property of a material, and this property is independent on V, independent on I. It depends on the nature of the material, the nature of the conductor. It depends on the length, area of cross section of that conductor. Okay, so R doesn't depends on V and I. And what is R? R is called the resistance. Now if we draw the VI graph of this from this equation, what will represent the slope of this graph? Draw it. VI graph, that means along x axis this is represent I, current, unit is ampere, and along y axis, that is voltage, is represent potential is volt. So you know the relation V directly proportional to I, so the graph will be straight line passing through this origin, and the condition applied here, temperature remains constant. Okay, now if we draw of slope of this graph, what will represent? Draw it. This one, this point is represent suppose V2, and this initial point is represent V1, this point initial I1, and this point is represent I2, suppose A, this point B, and this point C. So the slope of this graph, slope of VI graph, that means tan theta. So tan theta is equal to, you know, perpendicular by base, so this one is perpendicular, this one is base, because this angle is theta. So AB by BC. Now what is AB? this one is V2 and this one is V1. So AB represents V2 minus V1, V2 minus V1, and what is BC? This one I2, this one I1. So BC, this point is represent I2 minus I1, I2 minus I1. So this one is del V and this one is del I, and you know V by I is represent resistance. This one V by I is represent resistance. So the slope of this graph, the slope of VI graph is represent the resistance. Now question is, what is resistance? What is the definition of resistance? Resistance, which is defined according to this formula, that is V by I. Also you can say resistance is a property of material, is a property of conductor which oppose the flow of current. More the resistance, less the current. Less the resistance, more the current. Okay. So main part of resistance, that is it oppose the flow of electric current. Okay. Now question is, name the factors on which resistance depends. Before starting it, you just write down the unit dimension of resistance, this one. So the SI unit of resistance will be for potential, that is volt, and for current, that is ampere, volt per ampere, and this one is named as ohm. So this one is the symbol. So SI unit of resistance is ohm. Sometimes we can use the bigger unit of ohm, that is kilo ohm, mega ohm, giga ohm, etc. Now question is, suppose you have to define 1 ohm resistance. What will be the answer? This one. You have to define 1 ohm resistance. That means this one. 1 ohm resistance may be defined as of a conductor the resistance said to be 1 ohm when 1 ampere current flowing through that conductor with the help of 1 volt potential. That means in a conductor, when there is a potential developed, that is 1 volt, and current flowing through this conductor, that is 1 ampere, this ratio gives the resistance which is named as 1 ohm resistance. So this is the definition of resistance of 1 ohm. Now you have to find out the factors on which the resistance depends. So the factors is, resistance mainly depends upon two factors, the length of the conductor and the area of cross section. First point, resistance depends upon directly proportional to length of the conductor. When the more the length of that conductor, that indicates the more the resistance. And second point, resistance is inversely proportional to area of cross section of that conductor. That means when the area of cross section of conductor becomes more, the resistance becomes less. And there is another point, third point, resistance depends upon the nature of the material. If we consider a material of suppose nichrome and copper, nichrome wire and copper wire of same length, same area of cross section, but there is a different resistance. Nichrome wire has more than 16 times with respect to copper resistance. So resistance depends upon the nature of the material, and there is directly proportional length and inversely proportional to area of cross section. Now combining these two equations, what will happen? If we combine these two equations, R becomes L by A. So R will be rho L by A. There is a constant term, this term is known as resistivity, or it is called specific resistance. This constant term is known as resistivity. Okay. Now question is, what is the unit of resistivity? What is the SI unit of resistivity? Write it down. From here you can say rho is equal to this one, RA by L. So what is the SI unit? The unit of R, that is ohm, the unit of area, that is meter square, divided by length, that is meter. Meter cancel out, there is another meter, so this unit becomes ohm meter, right. So this is the SI unit of resistivity. Now similarly, resistivity is also the property of material. It depends, it varies from material to material, right. Now suppose you have to say what is resistor, what is resistors. A wire having some resistance is called resistor, And what is the symbol of resistor? The symbol of resistor, that is this one. This is the fixed resistor, but if we draw like this way, this represent the variable resistors. Okay. So according to according to Ohm's law, you can say the resistor are two types, ohmic and non-ohmic resistors. Ohmic resistor, that means which obey Ohm's law. So the graph of Vi will be straight line. Non-ohmic, which doesn't obey Ohm's law, so the graph not straight line, not passing through the origin, like semiconductor devices, PN junction diode, solar cell, etc., LED. So this is the basic of current, electricity, Ohm's law, resistance, etc. Now we will derive vector form of Ohm's law. How? You know the actual form of Ohm's law, that means V equal to Ri, and you know the V is a scalar quantity, I is not vector quantity. So V equal to Ri is not a vector form of Ohm's law. V is equal to Ri is not a vector form of Ohm's law. Now we have to establish vector form of Ohm's law. How? You know, in case of a conductor, draw it. In case of a conductor, there is a potential V. So this potential developed an electric field inside this conductor, and then this electric field expression becomes E by L. So from this equation you can say V is equal to E into L. This is equation 1. Okay. And according to Ohm's law, you know this one, according to Ohm's law, we can say V is equal to Ri. Now in the place of R, you can write rho L by A into I. Suppose this is equation 2. Now you compare equation 1 and equation 2. Equation 1 represent V, equation 2 represent V. So comparing equation 1 and 2, we can say E L, that is equal to rho L A into I. So L L cancel out, that is E is equal to rho I by A. You know the current per unit area represent current density, that is J. So this one is represent J. So this equation becomes J equal to 1 by rho into E, that is J is equal to 1 by rho. That means the reciprocal of resistivity is defined as conductivity. You know what is conductance. The reciprocal of resistance is called conductance. Similarly, the reciprocal of resistivity is known as resistivity. Sorry, the reciprocal of resistivity is known as conductivity. So this one is becomes sigma. So this is the form, this is the mathematical form. Here J is vector, electric field is vector quantity. So this is the vector form of Ohm's law, that is J is equal to sigma into E. What is J? J is the current density. What is sigma? Sigma is the conductivity, and what is E? E is the electric field. We have to draw the circuit, basic circuit. You consider a conductor connected to a potential V, then find out two equations. According to Ohm's law, V is equal to Ri, and when there is a potential V, they are set up an electric field E, which is given by this equation, E is equal to V by L. Now comparing this equation, we can establish J is equal to sigma into E. Okay, this is important part. Now again we derive resistance with the help of drift velocity. We define resistance in terms of drift velocity. So write it down fast, the expression of drift velocity. You know, we already completed the expression of drift velocity. So the expression of drift velocity, that is Vd is equal to E tau by m. This is a magnitude form. What is E? Electron charge. What is capital E? Electric field. Tau is the relaxation time, m is the mass of electron, and Vd is represent drift velocity. Now you know these types of relation. E is equal to V by L, V is equal to Ri, R is equal to rho L by A. So using this relation, what we can write here? You can write this one, E V L divided by m into L, because you know electric field is equal to dV by dr. dV is represent V and dr is represent L. Suppose you consider a conductor of length L. Okay. So this is the expression of drift velocity. Now you write down the relation current with respect to drift velocity. current I is equal to, you know the formula, NEA/VD. This is the expression of current, this is the relation of current and drift velocity. Now in the place of VD you just use this formula, that is NEA, and in the place of VD you write EV tau by ml. So simplifying, this formula becomes N E square A V tau divided by m into L, and in left side there is I. So what will be the value of I by V? That is I by V becomes this one, I by V becomes N E square A tau divided by m into L. Then what is the value of V by I? That is ml divided by N E square tau into A. So this is suppose equation 1. Okay, this is the expression of V by I with respect to m, L, N, E, tau and A. Now according to Ohm's law, you know the relation. According to Ohm's law, we can write V is equal to Ri. So V by I, which represent R. Suppose this is equation 2. You just check, you just compare equation 1 and 2. Equation 1 which represent V by I, this equation, and equation 2 which represent V by I, that is equal to R. So comparing equation 1 and 2, we can write, comparing equation 1 and 2, we can write ml divided by n E square tau A, that is equal to R, this one, because V by I is equal to R, V by I is equal to R, so R equal to this one, R is equal to ml n E square tau into A. So this is the expression of resistance. Another expression of resistance in terms of mass of electron, number of electrons per unit volume, electron charge, relaxation time, length and area of cross section. Now again you know the relation, that is R is equal to rho L by A. Suppose this is equation, this is equation 3 and this is equation 4. Now comparing equation 3 and 4, compare it. So when you compare equation 3 and 4, what will happen? That is ml by n E square tau A, that is equal to, you know, R, and you know R is equal to rho L by A. So here write rho L by A, you just check L by A cancel out, that is rho is equal to m by n E square tau. So this is the expression of resistivity rho in terms of m, n, E and tau. You know the basic expression, that is R is equal to rho L by A. So from here you can write rho is equal to RA by L. So this is the basic form, and this expression with respect to n, E, tau, etc. So students, you just think this is the property of a material. This property doesn't depend upon the dimension of conductor, but it depends upon two factors, two important factors. This one, rho is directly proportional to, rho is inversely proportional to n. This n, what is n? N represent the number of electrons per unit volume. We already derived, you just go back to your previous lecture and go and watch it. N is represent the number of electrons per unit volume, okay, and this factor rho is again inversely proportional to 1 by tau. What is tau? Tau is the relaxation time. So resistivity is depends upon these two factors, and this is a very important part. So this is the part we already derived Ohm's law, resistance, resistivity, vector form of Ohm's law. Now using this formula R is equal to rho L by A, we will solve some important numericals. Just check problem 1. Problem 1 given a wire of 10 ohm resistance. Write it down first. Problem 1. A wire of 10 ohm resistance, R given 10 ohm, is traced to thrice of its original length. Suppose its original length L is represent original length. Now final length becomes 3 times of original length. This one is given, this one. Okay, so L dash is represent final length, so L dash becomes 3 into L. Now you have to find out the new resistance. Suppose rho represent original resistance, resistivity, original resistivity, and rho dash is represent new resistivity. You have to find out new rho dash, and you have to find out new resistance, that means R dash. So you just think, for solving these types of problem, you have to remember one part. You know the formula R is equal to rho L by A. This is the first case, and again we can write R dash is equal to rho dash L dash by A dash. This is the second case. Now here you think A into L is represent volume, area into length is represent volume for first case, length L, area A, and for second case A dash and L dash. A dash represent the new area and L dash represent the new length. So the product of A dash and L dash is represent the new volume, but the volume for two cases of the wire remains constant. That means AL is equal to A dash L dash. This is the basic concept. So according to this problem, first question, that is, you have to find out new resistivity. You know resistivity is the property of conductor, is the property of wire. It doesn't depends on the dimension of conductor, dimension of wire. So we can say the material is same. Here wire of 10 ohm resistor, that is wire is same. So resistivity remains same. Resistivity doesn't change. So first answer resistivity rho dash must be rho. Resistivity remains same. Why? Because the material are same. Resistivity doesn't depends on length and area. Second case, you have to find out new resistance. Okay, first of all you write R is equal to rho L by A. Now in the place of R you write value given 10, that is rho L by A. So suppose this is equation 1, rho L by A value is 10. Now for second case you write R dash, that is equal to rho dash L dash by A dash. So you know the R dash, that is rho dash remains rho, that is resistivity remains same, and what is L dash? L dash, that is equal to 3L. So write it down first, 3L, and when length increases 3 times, area decreases 3 times. As a result, the volume remains constant. Okay, when length increases, area must be decreased, then the volume remains constant, and vice versa. When length decreases, area must be increased, then the volume remains constant. So when length increases 3 times, its area decreases 3 times. So R dash becomes, the formula is 9 rho L by A. This one, 9 rho L by A, and you know from first equation we can write rho L by A is equal to 10. So this one becomes 9 into 10, that is 90 ohm. So this is the new resistance, 90 ohm, and new resistivity, that is the remains same because material same. Now problem 2. Problem 2 given, the resistance of a wire is R ohm. Okay, write it down first. Problem 2, the resistance given R ohm, this is the resistance. Now what will be the new resistance if it is traced to n times of its original length? Same. For first condition, R is equal to rho L by A. Now for second condition, R dash is equal to rho dash L dash by A dash, but you know rho remains same. So rho dash will be rho L dash. Here given L dash is equal to N into L, traced to n times of its original length. Original length L, so final length L dash becomes n into L. So condition same, when L dash becomes n times increases, area becomes n times decreases. So this one becomes n into n, that is n square rho L by A. And what is rho L by A? Rho L by A is the initial resistance. So R dash is equal to n square into R. The final resistance becomes n square times with the initial resistance. One important concept required here for solving these types of problem, that is the volume of a wire remains same. That means when length increases, area must be decreased. In same way, when length decreases, area must be increased in same way. Okay. Now solve problem 3. Problem 3 given same concept is quite different. Here you have to solve, you have to find out the percentage increase in resistance. Write it down first. Problem 3 given a cylindrical wire stretched to increase its length by 10%, length increases 10%. Suppose original length is represent L. So final length, which is represent L dash, will be L plus 10% of original length, that is L. So this one becomes L plus 10 by 100 into L. So this one will be 1.1 into L. So L dash by L, this one will be 1.1, this one. Suppose this one equation 1. Okay. Now you know this condition, A into L is equal to A dash L dash, volume remains same. So from here you can say A by A dash will be what? L dash by L, cross multiply, and you know L dash by L ratio, that is 1.1. So this one is also 1.1, A by A dash. Now you have to find out the percentage increase in resistance. Okay. Now suppose for first equation you can write this one, R is equal to rho L by A. For second equation you can write R dash equal to rho L dash by A dash, rho remains same. So what will be the ratio of R dash by R? So R dash by R becomes, write it down, rho L dash A dash multiple of divide by R, that means rho L by A. So that means there is rho L by A. So rho cancel out, this one is becomes L dash by L into A by A dash. Okay. So you know this value L dash by L, L dash by L is represent 1.1, 1.1, and you know what is represent A by A dash, this one A by A dash, this is also 1.1. So this one becomes 1.1 square. So this one will be 1.21. So this is the value of R dash by R. Now you have to find out the percentage increase in resistance. So what will be the formula for finding percentage increase? That means at first you have to find out change in length by original length into 100%. So change in length, that means L dash by L by original length, that is R. So this is the this is the increase in length into 100%. So this formula represent percentage increase in resistance. Now solve it, R dash by R minus R by R. So this one is 1 into 100%, and you know what is R dash by R? This one R dash by R value, that is 1.21, 1.21 minus 1 into 100%. So this one becomes 1.21 minus 1, that is 0.21 into 100%. So this one will be 21% around. So here the percentage increase in resistance, that is 21%. So students, this types of problem is important for your exam, for your board exam basically. So this is all about this class. If there is any doubt, any problem, tell me through this comment section, and stay tuned with this channel. Stay happy, continue your study. Bye bye.